from home. But I am a staff engineer at Qoria, and we do online cyber safety and security for kids and children in schools. And we work with a lot of schools to provide that service. If you want to connect with me, there are the socials. And I'd love to learn a little bit more about who you guys are. So any hands up if you're a student? Yep, cool. And if you've been working with a couple of years experience? Yep. And people who have really seen some stuff? Yep, a couple of people. And anyone specifically in the security industry? No one. Okay, cool. That's fine. And just a quick question. How many of you have deployed something onto the cloud and thought about security later on, or just not thought about it at all? Yep. Okay, that's pretty much everyone. Yeah. All right, cool. I thought so. All right. So this presentation, as you might have seen from the description, is talking about how we can make use of a few little security tips and techniques to secure your applications in the cloud. And we'll talk about identity and access management and what we can do with service accounts and roles. We'll also talk about how we can make use of those roles and accounts with the principle of least privilege. Then we'll talk about what a WAF is and how we can use it. And I'll talk about some case studies there. And finally, we'll talk about how we can, with a couple of tips, build better security into our Docker images that are produced with our build pipelines with only a little bit of effort. So, identity and access management, probably the world's most boring topic, but it is the most important because every single thing that you do on the cloud will interact with identity and access in some way, shape or form. But in short, IAM is you telling Google what you want to do in terms of permissions, and they'll make sure that it happens. So, for example, who can do what, where they can do it, when they can do it, and it's basically saying, you there, you're allowed to do this, you're not allowed to do that. And we'll talk about, and then the two types of principles that exist are service accounts and users. So service accounts are used by machines or bots or whatever you want to call them, and users are people, human people. And you can think of it, identity and access management, as like an internal authentication and authorization mechanism for your GCP resources. So for example, if you try to access an API that you're not allowed to do, for example, you've got a function and you're trying to publish a message to a queue, and you're not allowed to do that, or that function's not allowed to do that, you'll get 403. Essentially what you do is you present a token to the API that you're calling, and you say, oh yeah, I'm this service account. And the API, the Google API that you're calling will validate the token that you've provided. It'll check that you are who you say you are and that you've got permission to do what you're trying to do. And then it will allow you to invoke that service. So with that in mind, what is the principle of least privilege? So there's two types of principles. And they're both pronounced the same way, which doesn't help. But principles and principles. A principle is someone or some kind of actor, and a principle is a fundamental truth or proposition. So the way I remember the difference in spelling is the first one, pal. It's a pal, it's like your mate, someone you know. So it's some kind of actor, someone. And a principle is just the other one. And the principle of least privilege says that a service should only have the authorization and permissions to do what it needs to do in order to do its job. So our meme girl here is showing what can happen if you give a service too much permission. If your service becomes compromised, someone hacks in, they've essentially got free reign, and we'll talk about types of permissions in a minute, over your Google Cloud resources. They can start VMs, they can start machine learning cycles, they can spin up clusters of compute and cost you a huge bill. To do crypto mining is the popular choice because it gets the hacker money and it's untraceable, but by applying some of these principles, we can make sure that they're locked down. So how can we use this principle of least privilege in identity and access management? Essentially, we start off by identifying a business need that our application needs. So for example, let's say we've got a shopping cart service and there's an ordering service on the other side of that. So we need that order service to have access to read information from a database. So we create a role and we call it, say, DB access role, and then we give it permission to retrieve data from the database. And then we assign those permissions to that role. So give it permissions to read. If you need to write, maybe you would add write permissions. And then what you do is you create a service account, a principal, and you give it those roles. So in the example of a ordering service, let's just say we've got you've got a customer that's placed an order, and the ordering service looks up that information from the shopping cart, and it can read in the items that are in the shopping cart. And it has to go and place orders with the suppliers to fulfill that order. It doesn't need access to write to the database. It just needs permissions to read from the database. Another permission you might want to give it is a secrets accessor role. So let's say that the account for ordering is placing requests with the suppliers. The suppliers might need an API key to be included with that request. So this is where you might store an API key and you could have access to read from that role. On the right, there's a QR code that you can scan. It's a blog post. It just talks about how we can do that with code. There's examples in there and there's some source code if you want to copy that in. It's a blog post I wrote about 3 months ago, something like that. So yeah, we can give our service account multiple roles. So in this case, we would give it 2 roles that we've created, a DB access role and maybe a secret accessor role. And there's different types of roles as well. So you can create a custom role, which is one that you define yourself, so something specific to your business needs. And there's also a bunch of predefined roles that Google Cloud provide that you can choose. So one of them is secret accessor role. And this slide deserved its own slide because it's just so important. The default compute engine service account, if you have just created a GCP project and you assign, like you spin up a VM and you've got your service running on it, by default, it will use this default compute engine service account. And you can see in the search that I've done there, you got about 7 million results about not using the default compute engine service account. But you can see the very first result says, and it's from the GCP documentation, it says that it comes with the editor role. And what is the editor role? The highlighted screenshot there is an editor role lets you create and delete resources for most Google Cloud services. So if you think about every single service that Google Cloud offers, this editor role allows you to delete resources, edit them, change them, create them, and do all kinds of things. So it's hugely wide-ranging in terms of permissions. So just don't use it. Create your own role. All right, enough about roles and IAM. How about a WAF? What is a WAF? Does anyone know what a WAF is? One person, awesome. It's not this. I wish it was, it's not. As delicious as a waffle is, it's actually a web application firewall. Far more boring, but it's called Cloud Armor. GCP's flavor of it's called Cloud Armor. And personally, I think this should be the mascot. Literal cloud armor, but it's not. It's this. Nonetheless, it should be that. But anyway, how can Cloud Armor help my web app? Now, who's familiar with the OSI stack? Yes, a few people. Anyone who's done computer science will probably know it. It's the 7 layers, and Cloud Armor allows us to protect our web app from some of those layers. Specifically, layers 3 to 7, we have some control over. So I'll talk briefly about them, but probably the most interesting one is for us is layer 7. But you can use rules in a web application firewall to control different types of access across to your application through different parts of the stack. So in layer 7, things like API calls and mail, if you use that, SMTP requests, HTTP, that's all layer 7 stuff. Going down the stack a bit, there's IP-based rules that you can set up, and they are for whitelisting and blacklisting. So an example might be if you want to build an internal service just for your company, but you want to deploy it onto Google Cloud, but you only want your company to be able to access it. There's a multitude of ways to do this, and one of them is with Cloud Armor. And you can say, okay, well, no one can access my app except the IPs based on the whitelist that I've got set up. So you might say, okay, well, anyone coming from the Office network is allowed to access this website. And so then that IP-based rule will say, okay, is the caller's IP address in the list? Yep, great, let it through if it's not. Equally, you can blacklist certain IPs. So if there's IP addresses or ranges as well that you want to blacklist, you can do that. And then there's other types of rules similar to IP, which is geo rules. So you can ban certain countries or redirect certain countries' traffic. Some examples might be, if going with the web shop example, if you've got users in Germany, for example, or Europe or wherever, and they want to make a request to your service, you might want to redirect them to a different API which serves European traffic, and therefore they'll get cheaper shipping and that sort of stuff. Alternatively, you might have your company that you work with might decide that as part of the war that's going on with Russia and Ukraine, you might want to block traffic from Russia. So you can do that too with these geo rules. And yeah, Cloud Armor also comes with the usual googly goodness that you guys are probably familiar with, of monitoring visibility and logging. There was an excellent talk just before in the other room about serverless deployments, and the guy talked about tracing and logging and that sort of stuff, and yeah, Cloud Armor comes with that, so it's really worthwhile having a look. But how can it help my web app specifically? And this is this case study with Up. You can scan the QR code for that one. It's a Google post. Does anyone bank with Up? Yep, one person, cool, two. Yeah, so Up is a neobank, and they were born in Melbourne about 5 years ago, something like that. And they recently been integrated with Bendigo Bank. They always used Bendigo Bank, but I think Bendigo Bank bought them out recently. And there's a really interesting case study there about how they use Cloud Armor to mitigate a bunch of threats. But what's awesome about Cloud Armor in this use case here is that it uses machine learning to understand the usual traffic patterns that are going to your website. So with the bank example, this isn't on the blog post, but let's say you have a bank and this is on an app only. So there's no web interface for this, it's only on app. So it'll understand, the machine learning that's applied to your application will understand access patterns and those sorts of things. So if it sees requests coming from a browser or a non-iOS or Android device, it's just going to block it, because it's like we don't have clients that access the Up service legitimately that don't use those clients. So it'll understand that and it'll surface up those anomalies that you can either action later on or explicitly deny until you come and have a look at it at some point. And other things as well, like, all of a sudden at 3 o'clock in the morning, there's heaps of traffic coming in. No one's doing their banking at 3 a.m. Like, no one is doing this. Even in Perth, it's going to be 1 a.m. here, and here it'll be 3 a.m. No one's doing banking, that much traffic. So it'll just start blocking those sorts of requests. And the other thing that's cool about Cloud Armor is the network-based threat intelligence, which is really interesting. So it can block known bad traffic and also known IP ranges. So an example might be other clouds. So if you've got an application and your primary users are end users, like customers, they're not going to be using another cloud to access your app. They're going to be using their home internet, or they're going to be using their Telstra or Optus or Vodafone mobile phone to access the site. So by default, you can just block other clouds, because it doesn't make sense that someone from another cloud would be accessing your app. And other things like Tor exit nodes. Anyone familiar with the Onion router? Yeah, a couple of people. So for those who don't know, the Tor or the Onion router is a way to mask your identity and your origin. So an example might be like, if you're just browsing the internet and you just want to sort of remain as anonymous as possible, if you run a news website or a blog Like you probably don't care where people are coming from. People want to read your posts and you want to serve them ads to make some money or something. But if you have a bank, you're going to care where people are accessing it from, especially if like the majority of customers for Up are Australians because they're an Australian bank. They're going to be accessing it from Australia. There'll be people travelling, of course, but by and large, it's going to be from Australia. So if you suddenly see over time a huge influx of traffic from, I don't know, Spain, then yeah, it's going to sort of raise alarms. So that sort of intelligence is really interesting. And Cloud Armor there's an interesting case study here, which I'm just going to talk about. It's got serious power. And it was built internally at Google for their own purposes, like most GCP products before they released it to the public for consumption. And they recently had a blog post a little while ago, and I'll share the slides if you don't want to read that post on your phone, but 46 million requests per second at peak was a application that got hammered, so one of Google Cloud's customers got hammered by a DDoS attack. And distributed denial of service attacks, if you see in the quote there, over the past few years, Google's observed that those distributed denial of service attacks are increasing exponentially. So every year there's just more and more of them. And with the amount of computing power available by either hacked machines or just cloud providers, the ability to spin up compute on demand has meant that the severity of those attacks is getting worse. But Cloud Armor protected this particular customer's web app from an attack. And that time scale, by the way, down the bottom there in the graph is 10 seconds. So you can see that it flatlines for the first 15 seconds of that graph. And then in like 8 or 9 seconds, it like peaks from 0 to 46 million requests hitting that API per second. So that's easily enough to overwhelm any service. But because they had Cloud Armor in place, it just absorbed everything. And Google runs like a lot of services that get a lot of traffic. So you can think about like YouTube and Gmail, Drive, Photos, all that sort of stuff. They probably put something like this in place to protect those services, so that if you want to see your photos on your phone, or if you want to check your email or whatever, that it's always available to legitimate customers but blocked from bad actors. And then you can see requests per second in the millions, peaked at 46, and then over the next minute, I suppose, it sort of dropped off. But it still was at the 12.5 million requests towards the end there. So yeah, there's a lot going on. So that's how sort of Cloud Armor can help sort of protect from that point of view. Okay, let's change gears a bit, talk about container security. Does anyone build applications with containers? Yeah. Okay, cool. Thought so. Its popularity has exploded since the advent of Kubernetes, which is only 8 years old. It's hard to believe, but yeah, it feels like it's been around a long time. But Kubernetes is only 8 years old, and the use of Docker, whilst Docker is a little bit older than Kubernetes, its popularity has really only grown since the orchestrator has been released publicly. And if you've ever built a web app or any kind of software that's served on a cloud or in a data center, and you need to be able to scale out horizontally, then yeah, containers are a very popular choice, especially because it solves the problem of it works on my machine. And tutorials and quick starts will get you some of the way. Like you'll be able to get your app built and deployed, probably, and it will probably work. But then what happens after that? Like the blog post just ends, and then what? If you get attacked, you have no idea about what's going on. And there's so many containers based images to choose from. So if you're a Node developer or Python or something, you might just go from Python latest, or you've got to pick the right one. So how do you choose? For example, with Golang, if you want to build a Go web app, you've got version 1.20.4-bullseye, then you've got 1.20-buster, you've got 1, you got latest. And these all point to the same thing currently, as of when I wrote this presentation. But how do you know what to choose? And smaller or larger Docker images, there's been like some chatter about this, and does it make a difference? Yes, it does. Not from a performance point of view, sorry, but from a security point of view, absolutely. And I'll talk about that in a minute. And does anyone deploy on Alpine with Alpine Linux? Yep, two people, yep, cool. Did you know there's a difference between Alpine's implementation of the C libraries and not? Yes, okay, that's interesting. Most people don't know this. So Alpine is a popular choice because it's a much smaller base image, but it uses a slightly different implementation of the C libraries. It uses, I'm probably going to pronounce this wrong, Muzzle or Musel, M-U-S-L. But most other operating systems use glibc. So when you're developing like locally on your Mac or on your Windows or Linux box, you're going to be using glibc, most likely. But when you deploy, and for those who use Alpine, there is a subtle difference. And most of the time, it doesn't get picked up because it's not really a problem. But if you ever get weird application errors, it's most likely to do this. And it's really hard to figure that out. So I just thought I'd point it out because when you're building with a container, it's really popular to use Alpine. So let's talk about Scratch. Has anyone heard about Scratch? One person. Okay. Scratch is nothing. It's like a nothing operating system. There's nothing in it. There's no file system, there's no command line, there's no terminal, there's just nothing. So what do you do with it? Well, you use it in multi-stage builds. And for those who are unfamiliar with what a multi-stage build is, you use multiple Docker images to build your application, and you end up with a single application which has just what you need in it. This comes back sort of applying that principle of least privilege. You're giving your application exactly what it needs in order to build. So in this example, I'm building a Go app, and this is a copy-paste of my side project that I'm doing. So it's called Scorecard, don't worry about it. But that's why it says that there. But this is a literal copy-paste of an app that I've got deployed at the moment on Cloud Run. So you can see it uses Golang version 120 as its building or base image to build from. And all it does is it sets up a working directory, and step 3 there, or the line 3, is just to add everything from my code repo into the Docker builder. And then I run go build, and I pass in a couple of flags, and I end up with a single binary. And then in my Scratch image, I've got 2 steps which copy from the builder image. It copies over the certificates that it might need if you're doing SSL termination, and it also copies from the builder the binary that was built. So what you end up with is a Scratch image which only has your application binary in it, which means that your attack surface is drastically dropped. And you also end up with a Docker image size that's, well, in this case, mine's 11 megabytes for an entire web app that runs a backend. But the intent there is that the Docker image only has exactly what it needs to run, and it doesn't have anything it doesn't need. So things that it doesn't need would be a command line. You're not going to use a command line in production. You don't need one. And if you don't have one, should you get hacked, there's nothing that a hacker can do because they haven't got a command line to run any commands, which is great. And other things like file systems, it doesn't have any unnecessary libraries or dependencies in there that it doesn't need. So one of the on line 4 there where I've got run C Go enabled, what that's doing is it's telling the Go builder to take everything that it needs to run independently so that it doesn't need any of the operating system dependencies that it might usually depend on. All right, almost done. Kevin Mitnick. Anyone heard of Kevin Mitnick? Probably not. Okay, he is in the security industry, he's a really well-renowned hacker. And he has this quote. the best way to defend against an attack is to not be attacked in the first place, which sounds dumb, but it makes a lot of sense when you think about the things that you can do to prevent that attack from happening. So with all those things we've talked about today, so identity and access management, the roles, giving the application exactly what it needs to build and nothing else, that sort of stuff, putting firewalls in place, that's making sure that that happens. We don't want to be attacked. So making sure that we don't get attacked to begin with is the best way to defend ourselves. And at the beginning of the presentation, I asked who doesn't think about security until after they've done something. Turns out this is actually a stat. 92% of people do not think about security until after their app has been deployed or never think about it. So if I can give you one takeaway from this presentation, it's this. Only give the application the things it needs to do its job. That's all you need to know. If you can do that, you're going to be in a really, really good position to keep your web apps secure on GCP and any cloud provider. Thank you very much. Any questions? Yeah.
Does this tool keep track of everything that's from the Tor browser and then block it? Okay. How does it keep track if it's from another cloud provider or if it's from a Tor browser?
How does what keep track?
How does the firewall keep track of if it's from another cloud provider or if it's from a Tor browser?
Okay. For the known bad traffic stuff, just go back to that slide here. This one. So Google has keeps a track of or record of known bad IPs or IP ranges or known IP ranges. So Google itself has its own IP ranges, public internet IPs that it's been assigned that it controls. So other clouds can do this too to block Google Cloud traffic, but it also knows the IP ranges of AWS and Azure. And Tor exit nodes are public on the internet because you have to have, that's where you're coming from. So they do pop up all the time. So it's like whack-a-mole, you knock one down and another one pops up. But it has so for example, AWS and Azure and GCP will have their public IP addresses listed. So it knows about them. So yeah, does that answer your question? Yep.
When we were implementing WAF rule set for our application, that time we were implementing for AWS.
Yep.
So that time we saw there are many rule sets available in the marketplace, but performance of them and the cost is obviously a factor. So that time we noticed the one that we bought, which was having good ratings and good reviews, it was not following the standard rule set that we were thinking about. So in your opinion and your experience, do you recommend any WAF rule set or any standard implementation that you have done or followed?
Yeah, like any architecture question like this, the answer is always, it depends. What I would suggest is having a look at the OWASP site, if you're not familiar with that one. They've got a bunch of like top 10, for example, rules that you can apply. But it also might be specific to your use case. Like, for example, in this slide, it's got the up banking. So they will have certain things like HTTP requests on a public web server are just going to be offline. It's all going to come through API calls, right? Because they've just got a banking app. They don't have a public website. So you might adjust your rules based on your use case. So there is no one silver bullet, unfortunately, but definitely one of the best places to start would be the OWASP top 10. So you can see just there at the top one. Google Cloud actually provides this as an option as a predefined rule. The www project top 10 is a good place to start.
I think our platform engineers opted for that one only. Like, they actually created their own rules and their own rule set, which was much more better than the rule set that were available in the marketplace.
Yeah, I mean, each vendor is always going to have their own rule sets, and some will perform better than others. But yeah, again, it just depends on your use case.
Thank you.
Yeah, no worries.
Any more questions? Okay.
It might be the same question. Some of my friends have been hacked while using ING Direct Bank and couldn't be refunded. But what's your thought or recommendation to that banking system now that is big problem?
Yeah, that's a really good question. I don't know the answer to that. There's lots of ways that we can improve security, and some of the big tech companies are doing that with the advent of passkeys. We don't have any regulations from APRA to use that, unfortunately. But passkeys is like a passwordless authentication mechanism, if you haven't already heard about that. Some other things that people can do to improve their security would be to have a physical second factor authentication. So with 2FA, often the second factor is like an authenticator that sits on your phone and that has a code that changes. And unfortunately, some of them allow you to back up your authenticators, but that kind of defeats the purpose of 2FA in the first place, because 2FA is something you know and something you have. But if you back up something you have, then it just becomes something that you know because it's just hidden behind a password somewhere. So it becomes one factor if you're backing up your 2FA keys. So don't do that in case people are doing that. The other thing as well is that SMS is inherently insecure. So where possible, I would avoid the use of SMS as a second factor authentication. Unfortunately, a lot of places require you to use it. Although that is changing. I think Commonwealth Bank and a couple of other banks that I've seen have like an internal authentication. So if you're online doing something and you want to send money somewhere, it will send a message to your phone app, which you then have to press yes to or whatever. And that's similar to a 2FA, but except it's not an SMS. It's to your phone. And similar with signing in, for example, some places will, like with Google, you can sign in with your phone as like a second factor. They don't send you an SMS, or they don't send you you don't use a 2FA code that's rotating. It'll just send a notification to your phone when you just press yes or no, and that's better. So that might be helpful.
Any more questions, guys?
Hello. On complexity, like implementing the WAF rules on our websites or on our application, what do you think? Is it easy to implement, or is it too much complicated and will require too much learning curve?
For implementing
WAF rules and WAF rule sets and the security in general, basically.
Yeah, so with Cloud Armor, you can either use the console and click stuff through and set it up that way. They make it quite easy to get like a basic implementation going. And there are a bunch of third-party vendors, software vendors, that you can use to also set up a WAF. The complexity really is going to be coming from specific requirements from the business, and where you have to override some rules and allow others through. That's where the complexity lies. Yeah.
Thank you.